Good evening, my favorite students. I welcome you, and I am very happy that your performance is very good. You are doing exceedingly well, students. With the beginning of year 2021, students, we have to work hard. What is our resolution for year 2021, students? Our resolution is both your resolution and my resolution also, because I work with my students, with my children, and our resolution together is that we will work hard. We will be determined this year to score high marks, full marks in our science papers, in our maths paper, in all the subject students. And we are not going to waste any moment of life. This is very important that you will not waste any moment of life. Will you waste? Tell me, will you waste?
No, sir.
Okay, you will use it. You can do studies, you can do creative activities, you can play sports, you can be a singer, you can be a dancer, you can be a painter, you can be artist, student, you can do any work you want in your life. You go for your passion, students. Whatever your dreams are, you fulfill them. In try to find purpose and meaning of life and go for it. You do what you love. Nobody is forcing you. You will do this. You will do science, medical, engineering. Nobody. You will do what is your love. Whatever you love, you go for it. ठीक है? Whatever is your passion. It is not necessary that you have to choose the profession which your parents are saying or which everyone is thinking. No. Wherever you feel you are good, you are better, you can choose that career. Therefore, student, the beginning of 2021 is very good, positive, and I wish you all the best in year 2021. I always say, if you think, believe, and act, you can do it. Nothing is impossible. You want 100 out of 100, you can do it. Who will do it? You will do it. By scoring full marks, you will work hard and you will score it. Is it right or wrong? Tell me.
Yes, sir.
Okay, then my best wishes to you, my dear students. I like you so much that I work very hard to find best of the best questions from different sources which are not in your NCRT book also, and try to see that you can answer those questions and learn, students. So our revisions have already started, student. As the revisions are going on in your school also, we are revising many important topics which will be there in your upcoming exams. So we have finished the chapter of work and energy, students, and we know that work is said to be done when a force acts on an object and a displacement is there in the direction of the force. You will say work is equal to force into distance into cos of angle between the force and the motion of the and the direction of the motion. So that formula we gave you for the work, student, because this is important point. When I discussed with you, student, what I discussed with you, student, when I discussed with you work, I told you we have defined F into S into cos of theta. This was important that the force is applied and that displacement is in the direction of the force. Otherwise, what will happen, student? If the force is acting perpendicular to the displacement direction, what is the work done then? Tell me, is there any work done? Is there any work done? Students, fast, 30 seconds. We are interacting with you every time. You are a participant. You are a participant with me, students. That is how we learn science. So if force is acting perpendicular to the direction of the motion, what will happen? Displacement direction and force, they are perpendicular. Is there any work done, students? Tell me, is there any work done? What is your answer? If the force is acting student in this direction, displacement is in this direction, then what happens, students? Is any work done here? This angle theta is 90 degree, then cos 90 is 0, and you are saying at that point work is 0. No work is being done. Then we discussed with you students the rate of doing work. The rate of doing work was very important because that is what we say power is the rate of doing work. The two machines could do the same work. One machine could do it faster than the other. So you say that the machine has more power. Rate power was defined as work done by time, students. Where what are the SI units of work, students? What are the SI units of work? Joule per, you have joule, work and energy are the same thing basically. Then you have joule per second, which we said watt. Power, the unit of power was watt, student, and we defined a commercial unit of electricity also, kilowatt hour, which is called 1 unit. This is a commercial unit of the electricity in which your house appliances come. And we told you that different appliances have different power rating, students. That tells you how many joules they consume per second. If I say the bulb is 60 watt, a bulb is 60 watt, student, what it means, it will consume 60 joules per second. So it consumes 60 joules per second. So it will be doing whatever energy it is consuming, it will be doing work, student. What type of work it will do? It may convert, you see, electrical energy into light energy. That is what the bulb is doing. And some heat energy is also produced along with that, students. So these terms we are aware of, student. And 1 horsepower is how much? 746 watts. So there's a relationship between horsepower and the watts. So all this you have already learned, students. Let us put up some questions to you before you will be answering these questions, and then we will be saying, okay. The first question on the screen is, student, potential energy of the pendulum at its extreme is. What happens when
Sir,
pendulum
it is maximum.
maximum?
Yes, sir.
Absolutely right answer given by Anya. You are so intelligent. I can't believe it that how your parents don't know about it. You are going to be genius people. Whatever I teach, physics, chemistry, or bio students, my objective is science. Everything is science. Your life is science. Food you are eating is science. Whatever world you are experiencing is science. My lecture is reaching you, student. It is science. Otherwise, how will I connect with you from such a long distance? Tell me. You are seeing my picture. You are seeing the blackboards. Everything is science, students. I want that we should take every subject as a science students so that we can learn it. We can learn it, then we will enjoy it. So, what is a pendulum? First of all, student, you know this is a pendulum. The bob of the pendulum is oscillating like this. Have you seen the pendulum, students? There is a string and there is a bob. This is a string and a bob. It is oscillating like this. It goes, it comes back, it goes, it comes back, students. And what is happening? It is swinging. This is the mean position, student. So what is happening? And this at the extreme position, this is the maximum height, student, it can take. We have told you the mechanical energy is total energy is conserved, student. Yes or no? Tell me. Which law is in total energy conserved, students? What was that law of conservation of energy?
Yes, sir.
Total energy is our mechanical energy. It is made up of kinetic energy plus your potential energy, student. Yes or no? Keep on interacting with
Yes,
me.
sir.
Energy should be high. We should have energy for studies. I should have energy for teaching. You should have energy for attending the classes and lecture student. Tell me, is it right?
Yes, sir.
Okay, you are also my teacher because you are interacting. You teach me a lot, student. You are so brilliant. You teach me a lot. So, what happens? Total energy remains the same, but kinetic changes to potential, potential to kinetic, but the sum of the two remains same. That is what you are saying, students. So, and it goes at the extreme position, students. In between, the pendulum has got the bob, the pendulum is having kinetic plus potential energy. So, here, what happens at the extreme maximum height? What will happen? It stops here, comes back, so that kinetic energy becomes zero, potential energy becomes highest here, and then it comes back. At this position, what will happen, student? At the mean position, which energy will be highest? Kinetic or potential? When it comes to the mean position, which energy will be highest? If the question is put in another way, what at the mean position, students of the pendulum, which is the highest energy, kinetic or potential? Tell me at this point, student, mean position, which is the highest value of the energy, which I am saying the mean position. What is your answer, students? At this position, mean position, which energy is highest? Here, potential will become zero and kinetic will become maximum. So that was the correct answer. Anya, your answer is correct. All right. You get 1 mark. For the pendulum, the kinetic energy of the pendulum at its extreme point is.
Sir, zero.
So 0.
Okay, correct answer given by Anya Vidhi. Correct answer. So what happens here? It comes at rest, velocity zero, then kinetic energy zero. A stone is tied to one end of a string being revolved in horizontal circular path. Stone is tied to one end of the string, revolved in horizontal circular path. The work done by the tension in the spring, students. The work done by the tension in the string is. What is the answer, students? Stone is tied to one end of the string. This is our stone. This is a string. ठीक है? Revolved in horizontal circular path, students. It is revolving like this. The work done by the tension in the string. What is the work done by the tension in the string, student? What is the correct answer? What will be the work done, students? What will be the, tell me, what will be the work done, students? Here, what is your answer coming? What, what is the answer coming? Student, this is moving in a circular path. What answer you are giving? It is obvious. Any doubt? Here, the work done will be what, student? Please attention to pi r. Pi r is a radius. The circumference is your 2 pi r. What will be the value of the work done, students? Any doubt? Are you giving the answer or no? Again, the work will be 0. No work is done here because you see where when the force is acting perpendicular, student, to the direction of the displacement, every time this direction, this is a tangent, student, 90 degree, the work here is 0. Next question on the screen, students. What should be the angle between force and displacement for maximum work?
Sir, zero
So
degree.
0 degree.
Okay, that is the correct answer which you have given, students. Here you could not answer the question, you know it, you knew it, you could not answer the question. So when, what should be the angle? That we have already said that W is equal to F into S into cos theta, students. This is a displacement. So if the object force is applied, displacement is in the same direction, and that time what happened, theta is 0, cos 0 is cos 0 degree is 1. So that is the maximum work will be done when the angle between the force and displacement is zero. This is the force and this is the displacement, students. When the force and displacement is zero, so maximum, what is the velocity of a body of mass 100 gram having kinetic energy 20 joules, student?
Sir,
Sir,
20
20 meter
meter
per
per second.
20 meter per second.
Yes, sir.
Velocity, what is the formula? Kinetic energy is equal to half mv square, students. 20 joules, half mass you have to convert into, this is gram, kilogram, students, because this is kilogram SI unit. So what will be the value of this? This will get cancelled. So 20 into 20 is equal to V square. Then V is 20 meters per second is the correct answer. 20 meter per second. The correct answer given by Anya and Vidhi. Next question on the screen, student. Potential energy cannot be positive, negative, zero, none of these.
Sir, none of these.
Correct answer given by Vedic. Potential energy can, if I am having any object, student, on the ground, if I lift it, then I am going against the force of gravity. Potential energy is negative. If the object is lying on the ground, potential energy is zero. If it is at a height, then its potential energy is positive. So that is, potential energy can be positive, it can be negative, it can be zero, is the absolutely correct answer. Okay, students, next question on the screen. A body of mass 10 kg moving with a velocity of 10 meter per second on a horizontal plane. On a horizontal plane. What would be the work done by frictional force if it comes to rest finally? Mass 10 kg moving with a velocity of 10 meter per second on a horizontal plane. What would be the work done by the frictional force if it comes to rest, students? What answer you are giving, students? What is the answer which you are giving? What is the mass of the body? 10 kg. Seventh question. Mass of the body is 10 kg. What is the velocity? 10 meter per second.
So B part will be the answer.
What is the value?
500 joules.
500. Which answer you are giving?
So B part.
500 joules.
Yes, sir.
Okay, this when the final velocity will become zero when it will come to rest, that you know already. So what will be the answer here, student? 10 kg mass, 10 meter per second. What would be the work done by frictional force? It comes to rest, student. So the body was having what energy? Kinetic energy. Kinetic energy is how much? Half into mv square. What is the value? Half 10 into 10 into 10. So 500 joules is the correct answer. You have given correct answer, Vidhi, because that energy will be the that energy is the energy after which it comes to rest. Therefore, this much work must be done by the frictional force, student, which stops the ball. The ball will be stopped how? This horizontal plane. This is my body, student, and it is moving. Then it comes to rest, student. The force which is opposing this is force of friction. So only when 500 joules will be the force which will be applied by this in order to stop it in opposite direction. That is the correct answer. Okay. Next question. Two bodies of mass m and 4m are moving with equal kinetic energies. What is the ratio of their linear momenta? momentum, students. What is the ratio of their linear momentum? Two bodies are moving with equal kinetic energies. If kinetic energy is equal, students, what is the ratio of their momentum? Momentum, what is the formula? Momentum mass into velocity. So what is the answer coming, students? You have body A, body B, mass is
So
M.
C part will be the answer.
Okay,
1
this
ratio 2.
1 is to 2, this is M, this is 4M, student, and kinetic energy is equal to half mv square. This is our kinetic energy, and that is half m into v is our linear momentum, half mv into v. So we can say that this is half. What is this? This is the linear momentum P1 into V, students. So what is the result? Their kinetic energies are equal. They are moving with equal kinetic energy, but what will be the linear momentum? So mass is different, then you can find the value of the velocity of the two bodies, then multiply by mass. ठीक है? Kinetic energy is half, first case, mv square. This is kinetic energy 1, this is kinetic energy 2. That mass is 4m into v1 the square and v2 the square. So what is the ratio? They are equal. Therefore, half m v1 the square is equal to half 4m v2 the square. Therefore, student, v1 is equal to twice of v2. And then p1 will be m1 into v1. Momentum of the second will be m1 into 2v2. So mv1 is equal to 2 times of mv2. What is the ratio then? P1 by
So 1
P2.
ratio 2.
1 is to 2. By divide this, 1 is to 2 is the correct answer. Is the correct answer given by Vidhi. Okay, thank you very much. Next question, students. Body is moving with a velocity of 2 meter per second. This body is moving with a velocity of 2 meter per second. The work done by 5 Newton force till the body to come to rest is when
So
body.
none of these.
Sir,
Which answer?
None of these. D
None
part.
of this. Body moving with a velocity 2 meter per second. ठीक है? And what is the work in the first case? Work is given 2 Newton, which is equal to force into displacement, student. Work is force into displacement. So when the work done by 5 Newton force till the body comes to rest, when 5 Newton will be applied, what will happen? This is 2 Newton and you are applying a force of 5 Newton. How much it is moving? Body, force. This is not work, this is force, student. So the work is how much? 2 Newtons into, ठीक है? The work done by 2 Newtons, and what is that velocity? Velocity is given. That is coming minus 15 by 2, 9 by 2, minus 9 by 2. None of these. Why do you say
Yes.
none of these? What is the reason? The Displacement work is force into displacement, student. So what is the force is 2 Newton, and velocity 2 meter per second. So final velocity will be what? Zero. Final velocity is zero. Initial velocity is 2 meter per second. So what will be the work done? Will be final velocity is zero. Initial velocity is how much? 2 meter. Initial velocity is 2 meter per second. ठीक है? And final velocity when it comes to rest is zero. So what we need is the change in the velocity. So here you are not getting minus 15 by 2, 9 by 2, and minus 9 by 2. Nothing. Okay. That is the correct answer. Next question, students. A girl of mass 40 kg climbs 50 stairs of average height 20 centimeter in 50 seconds. The power of the girl is student. Mass of the girl is 40 kg.
So C part will be the 80.
See, mass is 40 kg, 50 stairs height of average height. So total height covered is how much? H. How many steps? 50 stairs. 50 into 20 by 100 meters. ठीक है? How much is that? 10. The height is 10 meter. Height is 10 meter, students. So what is the potential kinetic energy? Potential energy or work here, mgh. Mgh is how much? 40 into 10 into 10. How much is that? 4000 joules. Time how much? 50 seconds. So power is work by time, 4000 divided by 50. How much is coming? 80 joule per second, 80 watt. That is the correct answer. 80 watts. Okay, students. Next question. Which of the following quantity along with energy is conserved in the universe, student? Which of the following quantity along with the energy is conserved? What is conserved, student? Energy is conserved, you are saying. What else is conserved? What else is conserved, students?
So density.
Then, no, mass, your mass is not going to change. Mass is conserved, student. Your mass is not changing. You know that we have already told you weight, your weight, other things can change, but your mass, whatever quantity of matter you are made up of, is not going to change, students. Mass. Okay, mass is the quantity which is consumed. Next question, students. Potential energy of a pendulum at its extreme position is
So
maximum. You already answered that question, student. That is the correct answer. Further question, a raised hammer possesses student kinetic energy, gravitational potential energy, electrical energy, sound energy.
Sir, B part, gravitational
That is
potential.
the correct answer. If a hammer is raised, student, what will happen? This is your ground. If a hammer is raised, this is our hammer supposing, then what will happen? This has a height, student, so it has gravitational potential energy. Which of the following condition is necessary for work to be done by a force, student? So force is applied, which is the necessary condition for the work to be done, students. When the work will be done. You know the answer. There must be displacement in the direction of the force. There must be component of the force in direction of the motion. Angle between force and displacement must be zero. None
Sir,
of these. What is the answer?
A part,
Which one?
A part.
A
There
is
must
the
be
correct
displacement.
answer. We told you that one important condition is always that work will be done, student, by the force if the displacement is in the direction of the force. It's very important. Work will be done on the object then only. So this is the correct answer, student. This is important statement. Important statement, student. Very important statement. There must be displacement in the direction of the force, student. You must know this. This is the point. Important point. If it is not written in the direction of the force, then what will happen? Then work may not be done, students. Work may not be done, then student. Next question is a force of 10 Newton displaces an object through 20 centimeter and does work 1 joule in the process. What it says, a force of 10 Newton displaces an object through 20 centimeter and does work of 1 joule in the process. Find the angle between the force and the displacement. Actually, now this sum
Sir,
involves
60 degrees.
cos theta. So, student, this what is the 1 joule? Force is how much? 10 Newton and 20 centimeter, 20 by 100 meter into cos theta, students. So what you are getting?
Sir, 60 degrees.
So this is 1 by 2. Cos theta is 1 by 2, students. Now this will be when cos theta, how do we say 4, 3, 2, 1. So 4, 3, 0. Cos theta is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Cos 90 is 0. This is 1 by 2. ठीक है? What answer you give? 1 by 2 is the correct answer. That is which answer you have given?
Sir, A part.
60 degree. Cos 60 degree. Cos 60 degree. The angle should be cos of 60 degree is 1 by 2. That is the correct answer. It involves some trigonometry, mathematics in this question. But this question you have seen I have taken from some source. So this was something different, student. Okay. Doesn't matter. You see that you are learning so many things which are important. That is the reason we are doing, students. We are doing that. Further, students, this we answered. In the figure, students, body is moving with a velocity of 2 meters. The work done. This we already done it. This question we already done is. Next question: a body at rest may have acceleration, energy, both A and B. None of this. If a body is at rest, student, what happens? Will what is the correct answer?
Sir, B part. Energy.
B is the correct part. I am sitting on the chair, student. I have energy. You are sitting on the chair and table. You are learning. You are studying. You have energy. I have energy. I have energy, but I'm not doing work. But I may do work as soon as I start moving from my chair, student. I can do work. So body at rest have energy. That is the correct answer, student. Correct answer. Next, potential energy cannot be positive, negative, zero. What is the correct answer, students?
Sir, none of these.
Yes, that is the correct answer because potential energy can be object lying here. Potential energy is zero in the ground. Object raised, student, against the gravity. If I am lifting if the object is moved against the force of gravity, this is negative. And if the object is, this is the height present lying here, it has a positive kinetic energy, student. It can do work. It can do work. Okay. Potential energy can be zero, negative, positive. This question has been asked so many times. Same is asked for the work also. Work can be zero, negative or positive. And a body of mass 10 kg moving with a velocity on a horizontal plane, what would be the work done by this? We have already answered the question, student. You already answered this question. What answer was given?
Sir, 500 joules.
Yes, already answered the question. This question, and of a string being revolved in a horizontal, the work done. This also you answered, student. Zero answered given. Okay. For pendulum, the kinetic energy of the pendulum at its extreme point will be this. We have answered. What was it? At the extreme point,
Sir, 0.
zero is the correct answer. Potential energy of the pendulum at extreme position is
Maximum.
correct answer. A body is thrown with a vertical velocity v0 upward in vertical direction. Its potential energy when it comes to rest for a movement at its highest point is, this is, the body is thrown with a velocity v0 upward in vertical direction. What will happen? Its potential energy when it comes to rest. This body comes to rest from here, student. Highest point, highest point. So what it was having? Kinetic energy, students, when it was moving. So what will be the value of the potential energy when it comes to rest? What is the answer, student? At the highest point, what happens? Kinetic energy will become zero, and the kinetic energy will get converted into potential energy because the total energy has to be constant, student. If it becomes zero, this total energy will be converted into what? Potential energy. Then what is the answer? What was the kinetic energy of the body? What is the kinetic energy of the body, student, which is converted into potential energy? What is the answer? What is the kinetic energy formula? Half m. This is the kinetic energy, student. At the highest point, this will become zero, and this energy will be transformed into what? Potential energy. So therefore, what will happen? The potential energy when it comes to rest is equal to the same as kinetic energy because this becomes zero. This will get converted into potential energy, students. Next question. What is the velocity of a body of mass 100 gram having kinetic energy of 20 joules?
So B part
B part,
20.
what is the velocity of the body of 100 grams kinetic energy formula is half mv square student. 20 joules is equal to half, ठीक है, 100/1000 kg into v square. Okay, this gets cancelled. Okay, 20. V is 20 meter per second is the correct answer. Next question. The kinetic energy of a ball of mass 200 gram moving at a speed of 20 centimeter per second is.
So B part
Same kinetic energy formula you have to apply, half mv square students. Half mass is 200 units. You have to be careful student, only question they give because grams to be converted into, so you convert grams into kilogram. Velocity is 20 centimeters, so 20 by 100 meters students. So what you are getting, which answer is coming? B part.
yes sir.
2 into 2 4. Okay. So, correct answer. Next question. A block is thrown upward with a kinetic energy of 1 joule. It goes up to a maximum height of 1 meter. Then the mass of the block is.
So B 100 grams.
Kinetic energy of 1 joule. 1 joule. It goes up to a height of 1 meter student. A block thrown with a kinetic energy of 1 joule. It goes to height of. Then the mass of the block is. So, mass of the block is maximum height, it goes to 1 meter, height is 1 meter student. So 1 mgh, then what is the mass you have to find out? G is 10, what is the height? 1, and what is this? So 1 by 10 kg will be how much? 1000 by 10 grams. 100 grams. Okay. Next question. Whenever non-conservative frictional forces act, mechanical energy is conserved, total energy is not conserved, kinetic energy is conserved, total energy is conserved. What is the correct answer for the students? What is the answer? What 28th student? You know already law of conservation of energy. So what should be the doubt here, students? When non-conservative frictional forces act.
So D part.
No, total energy has to be conserved, students. Non-conservative frictional forces are acting, what will happen? Non-conservative frictional forces are, then the energy is always conserved, student. So, what is the result of this? We will again check this answer because we should know what is the meaning of non-conservative frictional forces, student. Otherwise, total energy has to be conserved. Next question, student. Mechanical energy may conserve. Mechanical energy may conserve if non-conservative
Sir,
forces.
D part. Both.
Both B and
Yes.
C. Okay, that is the correct answer. Which of the following is not a unit of power? Which of the following is not a unit of the power, students?
Sir, C part.
What is power? Power is nothing but rate of doing work, student. What is this? You can express this into M into G divided by T also. So you can express one, joule per second is the correct answer. Work is force into distance. Work is M into G. That is your force into displacement, student. Force into displacement divided by time. Therefore, force is, if I put it in Newton meter per second, that is also correct unit. This is also correct unit. What will happen? This, if I put kilogram, what will be the result of that, students? Kilogram meter per second inverse. What is displacement? Meter. And what is time? S. So kilogram meter square s minus 3 second. That is also correct. Then what is this? So D is not correct. Which of the following is not a unit of power? This one. D. ठीक है? So students, the second quiz, you have answered question out of 30, 27 were correct. So 3 questions were answered wrong. That's a good score, good performance by the students. Your performance is excellent considering a lot of questions were given which were not taught to you. They are of higher level, but still you could answer most of the questions, students. Therefore, it's a good result and good performance. I congratulate you and thank you for participating and answering questions of work and energy with good spirits. Begin your new year with a good score. Those few questions were little higher standard, were not taught to you in the NCRT course, therefore you could not do them. Our best wishes, students. So this also ends the topic of work and energy question answer sessions, and we will meet you in our next class with revisions. What revisions you are interested, students? What revision you are interested? Tell me. We will do that part. You have matter surrounding, matter around us, atom and molecule, structure of the atom. We have gravitation, force, work, energy. What natural resources? In which chapter you want revision, student? Tell me. We will do the question answer sessions of all the topics we have to do. So revision will mean question answers from each chapter. Therefore, students, in the next class, we are going to discuss the revision and question answers of matter and surroundings. There will be a session on matter and surrounding. There will be revision and question answer session. ठीक है? Okay.
Thank you, sir.
So
Thank you, sir.
our revision with question answer start. Thank you very much. I will see you in the next class. Okay. Bye.